So here we have a compound with a given molecular formula, which is C4H10O3, and anytime you have an oxygen, you can ignore the oxygen because it's not going to affect the double bond equivalence. So simply based on the carbons and hydrogens, you can see how many double bonds you have in the molecule, if at all. So if you look at just C4H10, that corresponds to the formula CnH2n plus 2. Therefore the dBe for this molecule is going to be 0, because if you have 4 carbons, you should have 4 hydrogens, pretty much like butane. Therefore the oxygens here are not really causing any change in the dBe of this molecule, so this compound has no double bonds in it or no cyclic structures in it. That's the first thing. So an organic compound with molecular formula C4H10O3 shows properties of both alcohols and ether when treated with excess HBr. So C4H10O3 behaves like an alcohol and an ether, which means it has both alcohol group and an ether functional group in the molecule. So that's what it means. And when treated with excess HBr, you get 1,2-dibromoethane, which is this, as the only organic product here. So draw the structure of this molecule. That is the question. So we know that when we take an alcohol, so if we have a straight chain and you have an alcohol in the molecule and you treat that with HBr, it ends up replacing the alcohol with a hydrogen with a bromine, right? So you'll end up making a carbon-bromine bond where the alcohol was. And also when you have an ether reacting that with HBr, also is going to cause carbon-bromine bonds where the oxygen was bound to those two alkyl groups. So if we have ROOR with HBr, you're going to get RBr, and if there are two different alkyl groups, then you'll get RBr and R prime Br. So these are the reactions you want to remember so that you can answer this question. So we have 4 carbon chain or 4 carbon containing molecule, and that gives you only 2 carbon containing product, which means you are making 2 of these products. And now we can go back and reconstruct the original structure of the molecule. So wherever you have a bromine, you can now recognize that you either had an alcoholic group or you had an ether group based on these reactions. So let's make a dialcohol out of this. So if we had an ethylene glycol like that, reacting this with HBr, excess HBr is going to give you dibromoethane. But if ethylene glycol is the original structure, it does not match the original reactant formula, and it does not even match the fact that you're getting 2 of these molecules as the product. Therefore the only other way is to connect 2 of these ethylene glycols and make it into an ether, pretty much like this, where you have an oxygen and on one side you have an ethylene glycol unit. This is an ethylene glycol without a hydrogen, and convert this to another ethylene glycol unit on this side. And now if you treat this with excess HBr, you will end up making this product, because you will replace this alcohol with the bromine, you will replace this alcohol with the bromine, and you'll also break those carbon oxygen bonds and convert those carbons to a bromine carbon bond as well. So this is the structure of the molecule, which is consistent with the molecular formula as well as with the product structures. Okay. Alright, so in this problem we will try to understand what a chemical test can be used, what kind of chemical test can be used to distinguish between the pairs of compounds here.